Well, hello, everyone. We are live here today with Redis Monthly Live. You can tell it's Redis Monthly Live because we're going to talk about Redis. We do it every month, and it's live because imagination. So welcome, everyone. Good to see you all again. It's been 2 months since we've done this. We were off last month because of the Martin Luther King holiday. In the U.S. here, it's President's Day, so I guess technically it's a holiday, but it's a little more of a banker's holiday, so some of us are working. Today, I've got Simon Priggett, who is I guess Simon's my boss, aren't you, Simon?
Technically, yes. I'm the developer advocacy manager at Redis, but I still do a lot of developer advocacy content, and I'm currently hiring for a Python dev role. So if you know anybody, please hit me up. My Twitter's down the bottom there.
Yeah, it's a pretty good gig. It's great. You get to work with Simon, but unfortunately, you would also have to work with me. So. And in addition to Simon here, we have our star of the show today. We have Fernando Doglio, and he's coming to us live and direct from Spain, right?
Correct, from Spain. Hi, everyone. I'm excited and nervous, as you can see, to be here and to talk about Redis.
Oh, well, welcome. I'll do a quick little agenda here. I've kind of touched on it already, but let's go ahead and. These are our speakers today. So Simon is going to be doing our little Redis tidbit of the month. He's going to be talking about streams. And Fernando has a talk on creating a reactive architecture with Redis, or around Redis, which I think sounds super, super cool. I work for Redis, so I know all about streams already, but reactive architectures sound very exciting. So that's our plan for the day. I usually like to ask sort of a stupid question, a Redis related question, before we get the show going. So let's go ahead and do that. Let me remove this here so we can. There we go. So what's the and this may tie into your talk, Fernando, and Simon. What's the most unusual thing that you've used Redis to solve? What kind of problem have you solved with Redis in an unusual fashion?
All right.
Like, stupid Redis tricks. That's kind of what I'm looking for. Right. Do you have something, Simon, as well?
I built a price drawer using sets. So I have like a little talk where we do a thing where you go and sign up with your GitHub ID, and then it stores your GitHub ID in Redis, and it pulls your profile and caches it there. So you just get someone's avatar and all of that. And then it puts you into a set, and then we add like another set of prizes that you could possibly win. So like, t-shirt number 1, t-shirt number 2, whatever. And then there's just some logic when you press the button that just keeps pulling things out of sets until one's exhausted. And it's like, you've won this and they've won that and so on. So that's kind of like somewhat overkill for that sort of thing, but it was a slightly contrived application for DevRel purposes. But I have run it at meetups and people seem to enjoy it.
In my case, I think that probably the word use, and it's kind of something I cover in the talk, is the use of the expire event on the key space notifications to trigger time-based events, essentially setting up like a 3-week TTL on a key to trigger something that has to happen in the future, automatically through Redis. Cool. It's not that weird, but I guess
Well, it's a cool example.
Yeah.
So I do lots of crazy stuff with Redis. Because it's kind of fun. Probably my favorite thing that I've done with Redis has been using Redis search. I've loaded up a whole bunch of Bigfoot sightings from a Bigfoot sightings database into Redis, and then I have a talk where I talk about Redis and Redis search and how to index your data. And it's just fun to be able to load like there's about 5,000 Bigfoot sightings into a database, and then be able to do keyword searches on it and say, I want to find all the Bigfoot sightings near Walmart, or I want to find all the Bigfoot sightings near a trailer park, that kind of stuff. And so those are always kind of entertaining. And so that's probably one of my weird things I've used Redis for. So I see actually there's a couple questions in chat right now already. So I'm going to go ahead and bring one of these up. We've got, hello.
Right.
So Damien asks, by reactive, do you mean any use of the reactive framework, the reactive Pi, the reactive JS, etc.?
No, I don't. I mean, everything reactive is based on the same principles, I guess. But no, by reactive architecture, I mean one, and again, I'm gonna be covering that in the talk. But it's a architecture that allows you to have the usual client-server communication where you send a request and then wait for the response, to work reactively in the sense that you send a request and then when the response is ready, the server will let you know. So you don't have to stay waiting for something to change or for something to come back. That's what I mean by reactive. So your client can react to the service having the response ready for them.
Excellent. Thanks. Cool. So I just happened to see that question there, so I thought we could answer it now.
Absolutely.
I'm going to go ahead and do our little plug here, and then we're going to get Simon kicked off, and then it'll be Fernando's turn, and that'll be that. So here's our little monthly plug. Just a reminder. Of course, I work for Redis. Simon works for Redis, and we offer, open source. Redis is free. It's got all kinds of great features. If you want to take the features a little bit further, there's a lot more capability with Redis Cloud and Redis Enterprise. Makes the clustering a lot easier. There's a bunch of modules available, such as Redis Search and Redis JSON. So go and check that out. It's free. You can go out and get yourself a free database to play with, and check it out. So go out to redis.com/try-free for Redis Enterprise Cloud. Probably the easiest way to get up and running with Redis is you just go out, provision one, and then hit it with Redis Insight. So go check that out. We appreciate you helping us pay the bills. And that's pretty much all I've got. Simon, I think it's your turn. Let me bring your screen up here. I will get Fernando and I out of the way here.
So that's my screen. That's just my backdrop. Hopefully we got slides, because I'm now blind to StreamYard here. So Redis streams, which one of the facets of my day job is I run Redis University, which has online training courses for free. And there's an entire course about Redis streams that has like multiple weeks worth of content. So this is going to be the crash 5-minute, 10-minute version. So this is actually a slide I pulled from other presentations.
Simon?
No. Yep.
We can't see your slides. We just see a black screen.
Oh, no. Do you? Keynote. Let's try. Is that any better? Yeah, let's do it like this.
Okay.
Keynote failed there. Or possibly change of operating system recently. We'll see. Right. So, yeah, I normally use this slide in other presentations for introducing Redis itself. So what is Redis? It's key value data store, which hopefully everybody knows that because we're here at Redis Monthly Live, but there's always new folks. And what's happening here is this is the Library of Congress in the 1970s. And the woman there is pulling out a drawer of index cards. And those cards are actually in some sort of order, right? They describe books, and the books are cataloged and stored in order. So that drawer might contain all of the things that are about one particular subject or category area or whatever. And then each card is a book, and each card may have like attributes, facets of the book. So the name, the author, the title, all of that sort of thing. How does that relate to Redis streams? Well, a Redis stream kind of looks like that. It's a thing that lives at a key in Redis, so a singular key. So you can call it something like temperature, humidity, if we're tracking temperature, humidity values. And in the stream, there are a load of entries, and each entry itself has a set of name value pairs. So like a map of, temperature, 29 degrees, humidity, 81%, location ID, 24, whatever you want to put in there. So it kind of looks a bit like that. And here's a sort of more logical diagram of a stream. So as we see, a stream is a thing that lives at a key. So we've got a single key here called ingest : temp humidity. it's of type stream. That's built into Redis, so it's an open source Redis feature. You don't need to add anything to Redis to get that. You just have to be using Redis version 5 or higher, which most of you will be now because 5's been out for a little while. And streams basically model some sort of append-only log. So we can put messages or entries in there, and we can read them out again. But once they're in there, we can't change them. And they form a natural order. So the way that Redis manages streams is it gives each stream entry an ID. And by default, that ID is going to be a timestamp to millisecond precision. So what you see there across the top, the 153 numbers, are IDs that Redis has generated from the server clock when that entry was placed into the stream. So why do they then have a dash and then another number? Well, Redis is actually so fast at receiving these that it could, in theory, receive more than one per millisecond. So in that case, it uses a sequence counter. So we see the one in the middle there, 195-1, was the second one that was received at that particular millisecond. So they still have unique IDs, and they still form a natural order. What do we put in the stream entries? Basically, anything we want. You have to have at least one name-value pair, but you can put any combination of name-value pairs in there, and there's no schema per se. So your application may decide that all of your stream entries are going to have all of those fields we see here, so a location, a temperature, and humidity. But there's nothing in Redis is going to enforce that. The next one could have a completely different payload of 3 different name value pairs, or 10, or 1, or as long as there's something. And one of the ways we can use streams is as a sort of buffer to link producer processes that are putting out data. So in this case, imagine we have a whole load of IoT sensors, and they're in different locations around a factory or a workplace or a hotel or something. And every minute or so, they send out a location ID, a temperature reading, and a humidity reading. And we want to track those in Redis. So we can do that by forming a natural sort of time series. Whenever they land in the stream, Redis will give them this millisecond timestamp. And then we can have the producer just put them in there. And it's not really concerned with anything else that happens here. It just wants somewhere to drop these values very, very quickly and get on with making more of them. Then at the other side of the slide there, we have what's called a consumer process, or there could be several of these. And its job is to read from the stream and do something with the data. So it's basically going to take, in this case, give me the oldest message in the stream. And then it's going to ask Redis after that, give me the next oldest and the next oldest. And it's just going to keep going, doing something here. It's important to know that consuming messages doesn't remove them from the stream. So we could have multiple consumer processes doing different things. So we could do what's called fan out here. So we could have like one set of temperature humidities, and we could write them to, say, a data warehouse. We could have something that keeps a rolling average of the temperature, and we have something else that looks for a certain trigger level and then sets off an alarm somewhere. So all of these are linked together through the stream, which in this case acts like a buffer. So how do we add new entries? There's as you'd expect, a Redis command for that. It's called xadd, and this is kind of the only way of getting anything into a stream. And we give it the key name. Redis is key-based, so everything revolves around a key. So we're calling our key here ingest : temp humidity. So we're saying it's incoming temperature humidity values. We can supply an ID for our entry, and that ID needs to be bigger than any previous ID that's already in the stream. Or we could say to Redis, do the timestamp thing and do it for us. So that's what the asterisk there is. And then after that, we just provide it with a series of names and values that we want to store in the entry. So this works from Redis CLI, it works from all of the clients, and we'll have a look at this in Node.js. Then when we want to consume those entries, we want to read something back from the stream, there's a couple of ways that Redis allows us to do that. So with the IDs forming a sort of time series, one really sort of useful way of reading back is saying, give me all the things that happen between this point in time and this other point in time. So here I'm providing 2 timestamps and saying, give me all of the entries that were added in that time period. And we'll get back the 2 that are highlighted. Now I can go do whatever work I want with them. Remember, those remain in the stream, so some other consumers can work with them as well. I'm not reading them and taking them away. Then we may also want to consume the stream in a different mode where we do treat it more like a buffer. So rather than in this time period, we want to say, give me all of the messages since the last one I saw. So up there in the top, I can use this xread command, and I can say, I want to get 2 messages from the ingest temp humidity stream, and I want to start at message ID 0, which is the lowest ID possible. So that'll be the first thing there. And then once I've processed those 2, I take my highest ID from those 2, so the one that ends in 195-1, and feed it back into a similar command, the one that you see at the bottom. And now I'm pulling the next 2 messages out because we're saying, give me the next 2 whose ID are greater than the one that ends in 195-1. So this is all well and good if we've got like one consumer or several instances of different consumers that are doing different jobs and they want to each read the stream. So that alerting consumer in the bottom will read all of the stream. The data warehousing one will read all of the stream. But what happens if there's lots and lots and lots of data coming in? So we've got a sort of mismatch between the speed at which our data is being created and the speed at which some of our consumers can process it. So in that case, we would normally want to have multiple instances of the consumer and scale out that way, like you would with, say, a web server or other sorts of horizontal scale. And so we just add more instances. And then we kind of have a problem with the consumer method because each consumer would read the entire stream and they'd all do the work like 3-4 times over. So in this case, Redis provides something that we can't really go into tonight called consumer groups. And what you need to know about that is it allows multiple processes to say, hi, hey, I'm a member of this bigger logical consumer that we'll call, say, the AI classifier. And instances of that will all get a share of the stream so they can collaboratively process it and then move through it faster as a group. So we're going to have a quick look at some code now, and I will stop this guy for a minute and come back to Visual Studio Code. So obviously, this being Redis, we could have coded this in any language using a Redis client for that language. I went with Node.js, and Node Redis, the primary client for Node.js, has recently had quite a major release and has got a nice new interface with promises and TypeScript and a lot more affinity with JavaScript data structures than it used to have. So I went with this. Basically, we've got a producer and a consumer that we're going to look at here. A lot of this is preamble. We're basically just randomly going to pick a location ID, a temperature within a certain range, and a gap between readings, so somewhere between 1 and 3 seconds. And we are going to loop forever. Loop forever. We're going to create each of those random items. And then here's kind of the Redis bit. So we've got a single command here, which is going to say client.xadd, tell it the stream key name. So ingest temp humidity, pass it that asterisk, let Redis do the thing, and then just give it an object that's the payload we want to store. And what we'll get back from Redis is an entry ID. So it'll tell the client, hey, I added this at this moment in time, and that's your timestamp. That's like your ticket to say you got added to the stream. Then we'll go to sleep and wait for a random amount of time and do the whole thing again. So what I'm going to do is set that off running. And what we'll see it's doing is it's creating the random things, waiting the amounts of time. And then we can look at what happens inside Redis. So here I have Redis Insight that Guy mentioned earlier. I'm actually using a slightly older version of it. There's a preview that is an Electron app that runs more natively on your operating system. And because that's preview, it's not feature complete yet. So I'm using the older one because it has this really nice view where I can say, let's look at a stream. And when we click on it and turn this down to something faster, you'll see as the producer in the background is adding new values, off it goes, and we are basically generating new data, and I can watch that in real time. So we'll let that go for a while and we'll stop it. So unlike Redis PubSub, which is another way of building a sort of buffer or a system between two disconnected processes, streams are durable. So I've stopped this and all my stream entries are still here, and no one was listening to them, no one was consuming them, but I still have them. So what I can do now is go run a consumer. And what this process is going to do is start at the beginning of the stream, ask Redis for, give me the next message that is, or the next entry whose ID is greater than the one that I last saw, and we'll start at 0. And it's going to go through and just read them all back again. And then when it gets to the end of the stream, Redis will say, I don't have any more of those. And it's basically going to go into a loop waiting to see what happens. So we'll let that run in the background and let it catch up. What's important to notice is that this is a real-time view of our stream. The number of things in the stream isn't going down. So this consumer is reading things from the stream, doing its own work with them. It's not removing them from the stream. So how does that work? I'll switch to the consumer code here and make this a bit wider. So basically, we've got a similar preamble, and the consumer here is going to pretend to do some work for a given amount of time to just give it some entropy. So it'll pull a message off and it will wait between 1 and 5 seconds and then say, okay, I process that. We'll do something else now. I'll get the next one. So what it does is it also sits in a while true loop here. And when it starts up, it actually goes to Redis and says, hey, did I store a last ID? So did I memoize the last entry ID that I read in Redis in case I crashed or was stopped and needed to restart, so I can pick up from where I left off? And if it doesn't, it starts at 0, which is the beginning of the stream. And if it does, it uses that last ID. And then again, it's a single Redis command to get stuff out of Redis. So here we're saying I want to read from the stream, and I want to use a key name, pass in the ID that I last saw. So Redis will give us back things whose ID is greater than that. And then down here, I can say I want one message back, and I want to block for a number of milliseconds. So we're not constantly hard polling Redis. If there's, once we get to the end of the stream, which we have done now, it's finished, then it's going to sit there, go around the loop again, run this X read. That's going to wait a few seconds to see if other messages come in. And if they don't, it'll come back and we don't have a response. It'll just say, oh, there weren't any. And if we do have a response, the response is an array of message objects. I'm just picking off information from that. So what you'll see is if I go ahead and run my producer here, then the consumer in the background here should fire up almost immediately and say, oh, there we go. And now they are pretty much in sync. So as soon as the producer produces something, the consumer consumes it. But because the consumer pretends to take a random amount of time to do the work, and that's longer than the producer needs to generate something, eventually the producer is going to get ahead of it and we'll see a backlog build up again. And again, we can watch that here in Insight, so we can see new entries coming in. We don't have to have the producer up. So that was kind of all I got time for in this sort of length of time. If you're interested to know more, we have an entire Redis University course that covers streams. It's at university.redis.com. It's a multi-week course, and it covers consumer groups and recovery strategies and all of the things that you'd expect to put something into a real application. And that was it. So I'm going to let this kind of just run in the background, but do we have any questions?
We actually have quite a few questions.
Whoa, we do. Okay, let's see what we can do.
June Park asks, how can we scale consumers? For example, when producer appends too many at once, how can we ensure that no data is lost by exceeding stream max entries or memory limit? I think I know what you're going to say, but I'll let you answer it.
Yeah, there's like a sort of multiple things going on here. So I will bring up this consumer group that we've got here. So the way a Redis consumer group works is it allows multiple consumer instances to act as if they were one big logical instance. So they could catch up by basically you just throw more instances at it. And Redis manages for you a pool of which consumers seen which message and make sure that other consumers that identify as being in that group, which is just a string. So here we have something called temp humidity consumers. do not also see that message. And in this model, you use a different command called xreadgroup, and then you also have to use this other command down here called exac, which basically says, this also covers you for if your consumer is doing some work and then it like crashes. If you don't exac the message, so you do this at the end of doing some work, then Redis will Redis will allow that to be reassigned to another consumer in the group. So you can manage failures like that. In terms of how do you manage growth of the stream, you can trim streams. There's a couple of ways of doing that. I see we have a question about that coming up, so I'll come to that as part of
that. We had someone ask, this data is stored as binary, right? I'm not actually sure. Probably.
We do cover that a little bit in the course. It is internally inside Redis, it's stored as a radix tree. And that sort of drives some of the tree of the stream trimming strategies. So when you're trimming a stream in Redis, one of the ways you can do it is say, I want it cut down to say 1,000 entries, and you can do exactly 1,000 entries, or you can do approximately 1,000 entries. And if you do approximate, it's more efficient and faster because it doesn't have to walk the whole tree to find the 1,000 entries to delete. It just tracks how many are in each tree node, and it will delete a whole node or several whole nodes such that we're nearly at 1,000 and then not worry about the extras. That's not the only way of dealing with deleting from streams though. You can also run xtrim like you can run xrange. So in Redis 6, streams are added in Redis 5. In Redis 6.2, you can run a trim between 2 points in time. So you can say, I know we've finished with all the messages from yesterday or an hour ago. Let's purge those out of Redis. And the other way that we see people using this is you can use time to live on the entire stream, not an entry, but the entire stream, which is a key. And then you would have a stream for like, today's temperature, humidities tomorrow, and you keep them for like a week or 10 days or whatever your data retention is, whilst something else like a data warehouse consumer has logged them off to something that's permanent and more suited to very, very large data sets.
Cool. Conrad asks, is it possible to do a message bus using Redis streams? I answered this in chat and said, yes, totally possible.
Yeah, so
works well for
people have traditionally used like PubSub to implement, say, chat-like things in Redis. And the problem with PubSub is it's fire and forget. So if the consumer's not listening, there's nobody subscribed to that channel, you'll miss the message. Streams are durable, so we can go in here and do something like this. We can ask it how many are, if I could spell. And it'll say there's currently 170 on there. You can't do that with PubSub, and then I can basically do xrange humidity. I think it's 0 minus 1. Sorry. That's minus plus, sorry, wrong data type. There we go. I can say, give me everything you've got in the stream, and it will bring me all of them back because they still exist. So yeah, one of the main advantages is durability. So you build a messaging solution where people can log off and catch up on things since they were last online.
Let's see. We got an involved question. I think you've answered this already, but they were asking about using Maxling, missing data. It's kind of an involved question. This actually might be better for our Discord server, but
possibly, yeah. Let's see.
That's at discord.gg/Redis, by the way.
Yeah, the other thing you could do, and I've done this, I used to work with Firebase a little bit. I've done this in Firebase, is you could use, say, a Redis hash to track which consumers have seen which messages. So you could have like, a hash with message ID and then consumer that's seen it or whatever, or some other data structure to track that. And then when that data structure says all of your consumers have seen it, you know that it's safe to delete that. It's not really great for Redis because it's way more efficient to delete ranges of things than delete individual messages. You can do this. So you can, if you've got an ID, just do delete Oops. I need to give it a key. So we can actually say I can delete that. But Simon, you said there are append-only logs. Yeah, I did. And what xdel does is it kind of marks it as logically deleted, so it won't come back in the other commands, the read commands. And it will get purged eventually, but it doesn't immediately necessarily free you any memory.
So Damien asks, speaking of append-only, is how does Redis time stream perform upserts? Oh, he's asked, that's a time series question. So
yeah,
time
so
series
Redis
and streams are the same thing. Yeah.
Yeah, Redis streams is a built-in data type that you can use in any open source Redis. Redis time series is added through the Redis time series module from Redis Inc. And that allows more aggregation. And as you say, you can do upserts, and you can also do out of order inserts in Redis time stream.
Or time
you
series.
Cannot do that in streams. Sorry, Redis time series. You can't do that in streams. Once things are in the stream. So if I try doing something like xadd my stream, and I've been using star to have Redis set the IDs. I could have IDs already, like from another system that I'm just replicating data into. So if I had this is 1 and then name Simon, that's going to work. If I then do 2 and then name Guy, and then if I then want to do 4 and name Peter, so okay, we're up to 4. So should I be able to do this? The answer is no, because we've already had an ID that was greater than 3, and streams won't let us do that. And equally, there's no like X modify, so I can't go into entry 1 and change its change the value there. I can delete it and add another entry with a different value, but then 1 will have always had that unique payload, and streams guarantees that.
There's one last question here. I'm going to pop up here. There was some good conversation too. So the conversation in chat was excellent, particularly on YouTube. So yeah, I feel bad. Fernando's just waiting silently on the backstage. He's just hanging out. Oh, we could bring him on stage to say hi, I suppose. Here we go. Yeah. He's blocked out by the question, of course. So we can fix that. Question about consumer groups. What is the best practice to read and remove via consumer group to ensure deduplication of processing the same entry in a given stream?
Okay, so with a consumer group, let's this is going to be. So I've got a consumer here called test1. It's in a consumer group on its own at the minute. So it's just going to read all of the messages. But let's decide that it needs some help. Consumer group test. And this is the same code running with a different consumer ID, so it's just a different process. And what you can't see very easily is these are now sharing the stream, so they won't both process the same message. Redis has got a whole system in here, and Insight shows it a little bit that we can see here. Here's the consumers in the group. Here's how many pending messages they've got. And what that means is messages that they've read, but they've not sent an exec command back saying, yeah, I processed that and didn't crash. So Redis is dealing with splitting the stream between those two consumers according to when they tell it they're ready to read something again. And it's tracking how often they've done this. So like at this point, I don't think this updates in real time, but let's see. At this point, one of these has had a much longer idle time than the other one. It was off working. So you can dig in and track things like, have I got slow consumers? Redis itself will track which consumers get which messages. And as long as you use exec, it will make sure that it doesn't reassign them to others. And then you can use, there's an xinfo command and an xautoclaim command. And what those will do will allow you to see, oh, if this thing hasn't acknowledged its message and a certain time has passed, then you can have another process with logic that says what to do with it. So you basically like give it to another client, and then you can track that message. And if it keeps crashing all of your clients, you've got what's called a poison pill. So you've got a message with, say, bad data in it that's just going to crash every instance of the client ever. And you can then delete that off of the stream. So this is covered in the Redis University course in quite some depth. So I'd recommend looking at that probably in a more organized way than I can do it here right now.
Excellent. Well, that's all the questions. There was one comment directed at me, but they said hi there as Gandalf. So, thank you. Yeah. I actually am not a Unix kernel developer, even though I may look like one. So, excellent, Simon. Thank you very much. I'm excited about how much interest there is in streams. It's actually it's a pretty cool feature. It's one of those things that a lot of people don't know Redis has. And so, knowing that stream's there and it's just a key, and actually the consumer groups are stored in the same way as keys are, which is kind of how it works. Like it's atomic because it's using the same storage mechanism Redis uses for everything else.
The other thing that I'll just throw out there is if you want to come into the Redis modules world, Redis streams work really well with Redis gears, which is the thing that lets you run Python lambdas when events happen because there's a stream reader gear. So if you want to do the logic to do some consumer stuff and you want to run it in the server, then take a look at Redis gears.
Yep. Cool.
All right. Thanks.
Thanks a lot, Simon. Excellent talk. Excellent intro to streams. And if you haven't used streams before, do go check it out. It's a very capable bit of kit. So. With that, let's go ahead and remove Simon's screen here. And Fernando, are you ready?
Yeah.
So Fernando's going to share with us reactive architectures around Redis, which I think is, I'm actually very excited to see what you've done here. I have watched, I watched like the first 5 to 10 minutes of your YouTube video before I reached out to you. So I haven't watched the whole thing. I promise I'll watch this time. And then, Simon, I know you got to take off early because it's dinner time for you in the UK. So
it is.
So thanks a lot, Simon, and we'll see you. Okay. I'll see you tomorrow, but everyone else will see you the next time you stream.
You can also find me on Discord. So if you've got any streams or other questions, join us on Discord, and we will help you out there.
Yeah, absolutely. And while we're talking about Discord, really quick, let me bring up the little URL here. Yeah, there it is. So there's the Discord URL. So Simon and I are on there all the time. You ask us questions. And we'll answer them when we're in time zone. So, excellent. Well, thanks a lot, and I'll see you later, Simon.
Bye.
Bye. Okay, here you go. So with that, Fernando, the floor is yours.
Right. Thank you. I'm not seeing anything, so let me know if I'm sharing correctly. This talk is actually going to be overlapping a bit with what Simon said about consumers, producers, so on. But I'm not going to be focusing on streams, but rather on PubSub, which is something that also was mentioned in the chat. So anyway, quickly speaking and going over why I'm here, who am I essentially. I'm Fernando, like everyone said. Right now based in Spain. I'm originally from Uruguay. I've been working in this industry for more than 18 years. And I've done everything from web development to big data in the middle. Going through Redis was one of these pieces of technology that I fell in love with. So I've written and I've done a few also talks about it because I really, really like this technology, this piece of technology, and I think it's very versatile, as we've seen and as we're going to be seeing as well. So essentially, what I want to cover here, I'm not going to be going into a lot of code examples or anything. My point of view is more from the architectural point of view. Why? What is a reactive architecture? Why would you go with it? And kind of the place that Redis or the role that Redis plays in it, for me at least, and how you can use it to create one. So quickly, what is a reactive architecture and at a high level, right? So the classic and the classic client-server architecture that you have for web applications and basically the internet is you send a request and then you wait for the server to get back to you to do whatever it has to do and then get your response. That works. That is simple enough to make everything work. But there are some problems. If on the server side you have to do a lot of work, or if your server-side architecture is complex enough and you have to do a lot of processing, or whatever it is that you have to do that takes enough time, you will either get a timeout between client and server, causing the classic problem of lose of connection, or even if you don't, the user experience for your application can suffer because your UI might be unresponsive, or even if it's not, the UI will still somehow have to wait for the response to get back before enabling the user to do something else, right? So the idea behind a reactive architecture is that your client will send the request to the server and then forget about it. From the user point of view, you can keep working, you can keep using whatever you were doing, and the minute the response you needed is ready for you, the server will be the one sending it back to the client and letting them continue with their original task. That is, in essence, the time it takes for the overall, from the start of the request to the end, is potentially the same, but from the user perspective, the whole experience is different, and even from the user perspective, that could they will feel like it takes less time. So why I think reactive architectures are very useful, other than a lot of technical aspects that are covered here, are they allow for a very flexible and really fluid user experience. And if we move to more of an architectural point of view of what I just said, you have a lot of concepts that Simon covered already. You have the producer, the message bus, the consumer, but essentially, quickly, because this was already covered, everything moves around the message bus. That is your key feature. That is the key service that you want to have, and that Redis provides, as we'll see. That allows you to orchestrate potentially very complex architecture, not just one consumer, one producer, and potentially many consumers, but many producers that they themselves can be also consumers and then turn again into producers. There is a lot of message or event exchange that can happen in the backend that your users don't have to know about. And even that, if you don't go through this process, through this type of architecture, you will have to orchestrate somehow, either through code or through some other third-party service that will allow you to do that. The flexibility that the message bus gives you, and that this event-based or reactive architecture gives you, is that you don't really have to worry about the orchestration. It is given by the model, right? If in this diagram, microservice 3 and 2 are waiting for a message from microservice 1, they don't really have to know anything about it. They just have to know the type of message that they want to receive and where the message bus is, and that's it. They can worry about doing their own job and their own tasks, and that's it. That little world of them is all they care about. That separation of concerns and decoupling between the microservices is what I really like about this model. And if you follow here the steps that I laid out here, you see that the client application only works about the first and second step, which is submitting the request, sending the requests to the server, and then just subscribing to get the response. That's it. That's what I was trying to say before. They don't really worry about if they have to communicate with microservice 1 and then 3 and then 2, or what they have to do in between. They just worry about subscribing, and then the the response gets back to them on their own, on its own. So why a Reactive architecture? Kind of what I've been saying so far. It helps optimize the client times from the user perspective. It creates a very fluid experience that is key to a successful application. Personally, I found it that it simplifies the complex requests where multiple microservices are involved. The orchestration between them is trivial, essentially, compared to a more client-server standard communication. It's a lot easier to add new services, and this is another huge plus in my mind. When you have a predefined architecture this way, built this way, and you need to add a new feature or a new set of services or whatever, if these services can work with the type of events that are already in place, you can just add them to the architecture without modifying anything, and that is priceless, I think. You can, and if you need new services, new events or new type of messages, that's great. You just modify just a single places where they are produced, and that's what you need to modify. There is no extra orchestration. There is no, adding routes to services or letting them know where your new services live or whatever. You just create new ones and forget about them. And like I said, it also decouples a lot of the services between each other, to the point that if you play your card right, and in an ideal world, you could just create microservices to the point of using them as Lego bricks, and then just moving them between projects, or even creating different logical rules or business rules around them based on the type of messages that they produce. So it's really, really powerful. Obviously, nothing is right for everything. There are cons to this architecture. The two main ones that I always found is they're definitely harder to debug because everything is asynchronous. And given a complex enough architecture, your messages could not always be, following the same route, essentially through microservices. So trying to debug and understand where the problem is and where things are going wrong requires adding a lot of debug information and tracing the path that your events follow. So it's a bit harder, definitely. And I think it requires a bit of a mindset shift when it comes to defining architecture and developing these microservices. You're no longer worrying about client server or server microservice between microservice architecture, but rather triggering events and getting triggered as a consumer. So those are the two main problems I see with it. And like I said, there is no ideal solution. There is no silver bullet in anything around technology. So while this architecture is one of my favorite ones and a really powerful and flexible one, sometimes it's not the right one, and it doesn't really have to be. It won't solve all your problems, and it might also create new ones if you're not using it correctly. So definitely something it's just another tool to consider, but it shouldn't be your only one. So after that, and once we understand why I'm talking about reactive architectures, so what's the point of Redis? We all know what Redis is, and if you didn't, Simon kind of said that already, so I'm gonna skip this. But also kind of touching in what's already been said, Simon covers streams, which is a great new feature, well, kind of already, but from Redis, that allows for the creation of a message bus, definitely with persistence and a lot of great features. My experience has been with PubSub and QSpace notifications. I don't think there is a single way to build this. Definitely, it all depends on your needs and your context, essentially what you have to build and how it has to behave. PubSub is definitely a simpler implementation. If you don't care about persistence, if you don't care about losing messages, I think it's definitely a very powerful tool. You don't have to, like everything with Redis, you don't have to do anything special. You have it out of the box. And you can just use it as part of your same installation or same cluster. So it's definitely very powerful. And the key space notifications is something that I just find it really interesting, really powerful, and also not a lot used. Maybe I'm just like trying to go through the difficult path to achieve the same thing that you could achieve through another way. But I think really that key space notifications allow you to create some very specific type of events or behaviors that are just given by Redis through their use. So I think they're quite powerful as well, especially the expire event that I mentioned at the beginning of the talk. Well, yeah. So and finally, this going back to the idea of the building blocks of the Lego bricks, you with the scheme here that I'm talking about, and using the PubSub and the key space notification, especially, you can split behavior that you would otherwise have in a single block of code, in a single function, for instance, here on the left, and decouple to the point that you can just have reactions between pieces of code, between functions, without having to write in the code to orchestrate them. It's not just about orchestrating microservices, but to the point that you can orchestrate specific functions. The save user function here that calls a fake storage object that essentially would just be saving a record into Redis, for instance. If you have the right function subscribe to this specific key space notification event, you could potentially say that the welcome user function gets triggered automatically by Redis whenever a new user is saved, and you don't have to do anything. Is another way of thinking about reactiveness on a smaller scale, if you will. Not necessarily on an architecture level. While it does work that way as well, you could also have like a whole notification service that does this. You can go to the fine grain and modify just the set of functions and split your logic into reusable building blocks through these kind of mechanisms that are already provided by Redis. The one I definitely think it's a huge benefit and something I built in the past, and I built whole architectures around this, is the time-based events, which could be a pain to orchestrate otherwise. I mean, how many times have we seen cron shops doing regular rounds of things that that have to run every day or something like that, or have to go out every Thursday on every week, while they do work, and maybe not cron shops, but through Control D, I think it's called Control M, or other orchestrators, you could achieve the same behavior. I think it's kind of magical how you can use the same product that the same piece of technology that you're using for something else to also benefit from that kind of orchestration. Time-based events are trivial if you use the key space notifications coupled with the expire event, coupled with the time to live on your keys. You can just set a specific TTL on your key and make sure that you're subscribed to the expiration event of that key. While you don't get the value of the key, there is a trick of using shadow keys to get the data, save the data that you actually want on another key, and get the name of the key that expires on your notification on your trigger code, essentially. So you get the name of the key, get whatever you want out of it, and pull the data from the other key, use it, and then delete it if you want to. But that triggering, that reactiveness, I don't know how else to call it, around time-based events is it's so simple that I wouldn't really, having Redis already on my architecture, I wouldn't really go any other way, especially if it's not just something that has to regularly happen every single day at the same time, or every single week in the same day at the same time. If it's something that is viable, but depending on one particular event, then wait some time and then do something or check something. I think the key space notifications are very, very powerful. So, and I'm just promise I'm getting near the end. Reactive architectures, they're magical to me, at least, especially if you use them with Redis. They will allow you to create a very flexible and reactive UI for your application. They are super easy and very simple to expand and scale compared to other type of architectures. The orchestration is given by the message bus, which is a huge plus as well. And if you play your cards right, you can just you create them and modify them and move those microservices around as if they were Lego bricks. And if you add Redis to that mix, that has everything you need out of the box, right there for you to use. It gives you extra events through the key space notifications that are fantastic to things like time-based events. There is really no reason why not to use Redis for this. That's it. We're done. I don't know if there are any questions or comments.
Not a ton of questions. We did get greetings from Chile. So I thought that was kind of nice. I'm scrolling down through the list here. One person did talk about one of the other pros for building reactive applications like this is to reduce the domino effect in the event of service failures. So that's certainly true as well. So
yeah.
And so I had a question about time series, but that's not your talk. So we'll answer that. I said, how do I set up a time series that stores stats like a user likes in a day, week, month, 6 months, and a year? That's a big question. So I recommend going over to the Discord server and we can have a discussion there about it. I don't think, Fernando, you've used Redis time series. Probably not.
No, no, I don't have the pleasure. Sorry.
And I don't have the information off the top of my head, so I don't know that I have an answer for you. If there are any other questions, go ahead and drop them in chat really quick. Otherwise, we're going to wrap this up. Any other questions? We'll pause awkwardly for lag. Conrad asks, is there a simple step-by-step tutorial where one can learn the overall concepts, microservices, reactive architecture stuff?
I don't know if there is one specific, one particular place where you can get everything.
Aside from saying something like Pluralsight or something like that.
Yeah, but off the top of my head, I can't really recommend one, to be honest.
It's one of those things where, like I had someone asking me, as a starting JavaScript developer, where do I go to get started learning all this stuff? And I'm like, well, I don't know. I consumed all those resources 20 years ago, and I've just been evolving with the language, and so I don't know what the current resources are. And I think it's similar to things like microservices, which are big but established topics. Finding the beginner sites. Unfortunately, I never look at those either. So Couple thank yous. So June says thanks for the talk, and Aziz says thank you as well. So thank you everyone for attending. Always welcome. Always good to have viewers on the show here. So and thanks a lot, Fernando, for joining us today.
Thank you for having me. It was fun.
Got another Zephyr says thank you as well. So we do this every month. So I'm going to go ahead and put my screen on here every month. And next month, this month we had Fernando, who did this on rather short notice. So extra thanks there. So
no worries.
Next month we have Eric Brandes. I don't know how he says Brands. I don't know how Eric says his last name. I know I've met him. I just never said his last name. He's doing a talk called Crazy Like a Fox, using Redis as your database, just as the database for your application. He's done this with some applications he's built and sells. He's going to talk about his experience doing that. And so I'm looking forward to that talk as well. So tune in next month and check that out. And if you want to make sure you don't miss that talk, join us on meetups.redis.com/Redis Live. You can sign up there and you'll get an email saying, hey, Redis is going to come up. Redis Live is happening in a couple days. Make sure you watch. And you can subscribe to our YouTube channel. Probably something about liking and subscribing and smashing a button, that bell icon or whatever the cool YouTubers say all the time. But you can subscribe on YouTube and you'll see us when we go live. And you can also follow us on Twitch and see us live there as well. So, and if you want to get in and start interacting with us, with the team, we got Discord server at discord.gg/Redis. I'm on there all the time. Simon's on there all the time. A bunch of the team's on there. And you can get direct access to some of the developers that work on some of the stuff that you're using. So, if you're a Node developer and you use Node Redis, I know Label hangs out on the Discord server, and so you can talk to the author directly. And give us a follow on Twitter as well. And I think, one last announcement. We always need speakers. So if you have a Redis topic and you're interested in talking about it, reach out to me. Email me guy.royce@redis.com, and I will get you scheduled. I'll vet your talk. I mean, if it's totally irrelevant, I'm going to turn you down. But we will always need speakers. So reach out, please. Or just hit us up on the Discord server. And that is, I think, all we've got. Yeah, all I have left now is this pretty guy right here. So, that's what we got. So thanks a lot, everyone. And Fernando, thanks again for doing this on short notice.
Absolutely.
Do you have any last comments you'd like to make?
No, my pleasure, everyone. Thank you so much for sitting through my talk, and I hope, I sparked. If you weren't familiar with the concept or thinking about using Redis for this, I hope I sparked at least some curiosity.
Excellent. I think that's a great way to end it. So thanks again, and we'll see you all next month.
Bye.
Bye.